Hi, in this video we will learn about basics of R2 and R3. In particular, we will learn what are points, direct line segments, vectors, how they are related, and what are their differences. Let me start with the point that when I say R2, R3, what basically I mean by R2 is two-dimensional plane, and by R3 we mean three-dimensional space. So for R2 we have two coordinates or coordinate axis xy. For R3 we have 3x, y, and z. Okay, so let's start with the first component, first important thing, which is points. Well, the work we are going to do is that we have to identify points on both R2 and R3 by some algebraic mean. So here in this case, every point can be identified by its coordinates. What are the coordinates? In the case of R2 is just pair of real numbers, In the case of R3, it is a triple of real numbers. Well, in other words, to identify each point, we have two numbers. It's important that this is ordered, and the other one is for R3 we need three numbers. How does this work? Well, basically what you do, you look at the first component and choose that number on the real line for x-axis, and then go from that point you go in the direction of y for u2, and that point has the coordinates u1 and u2. In the case of R3, so we first do find u1 in x-axis. In the direction of y we go u2, and then in the direction of z, which is vertical, we go u3. The point we end up with this process is u1, u2, u3. Well, something important, the notation we will use for the convention that we will use for this book, for this course, is that we use uppercase letters like PQ for points. And the way we denote a point with name is that, well, if you have a point with coordinate u1, u2, you simply put the letter you have chosen for that, in this case P, in front of your coordinates. And for the other one is the same. Well, this is the convention your book uses, and we will use up to the end of this course. Well, examples of points, for example, we can have, well, P can be, say, 1 and -1. It means point 1, -1, we are going to denote it by P. Q can be, say, 1, 0 in R2. For R3, let's just say 0, 1, -1, and 2, 3, -1, and something like that. There is one important point in both cases. It's called the origin. Yes, The origin is where the x coordinate is 0, the y coordinate is 0, and in the three-dimensional case, it is 0, 0, 0. So that is what you need to understand, learn about the notation and convention for this book. Well, okay, so if that's done, then the next thing is directed line segment. Well, it is a directed line segment, and every directed line segment are fixed by the starting point and end point. So we denote the directed line segment. It is a line segment, but it has a direction from point P to point Q by, so we're going to choose a notation for the PQ is the directed line segment from P to Q. In other words, what we have here is that doesn't matter if it is in two-dimensional or three-dimensional. When you have PQ, the line segment starting from P to Q. Why I'm saying starting? Because there is a direction here. It has a direction. I put that one means that we start from P, we go to the end point Q. That is a directed line segment and PQ. In other words, directed line segment are given by 2 points, starting point, end points. One important case of directed line segment are vectors. What are vectors? Vectors are directed line segments starting from the origin. Not on other points, just the ones that start from the origin. So something like this guy here. Or if it is in three-dimensional case, a directed line segment which starts from the origin and goes to a point. So how do we identify vectors? So as you can see, it says directed line segment which already have starting point. Starting point is the origin. So to fix it, we need only the end point. First of all, vectors are identified, well, in case of R2 by pair of again real numbers. Well, here, for example, U1, U2. And in the case of the three-dimensional case, it's by a triple of real numbers. So U1, U2, U3. Well, right away you say that, okay, but we use exactly same kind of algebraic thing, a pair or a triple of real numbers to identify points. What is the difference between the point and vector here? Actually, the first thing is the notation. This is the notation of your book that we use lowercase English letters to denote vectors. Well, this is just the names. There is one thing that you will see me doing. So, for example, I will use U or V or something like that, something U, V. But in your book, if you look at your book, you will see that it's bold lowercase. Since in writing I cannot do that, I will put an arrow up there. So vectors are going to be denoted by lowercase English letters by an arrow. When you check in your book, it's just lowercase but bold lowercase English letters. So, and the other difference with point is that you don't put that right up front. You do this, put equality, or U here is U1, U2, U3. And before we call these numbers the coordinates, now these are going to be called components of vectors. U1, U2, U3 are components of vectors. The vector that we choose. Well, again here, examples, you can do different example, but there is, well, example, let me write this. For example, U can be, say, 1 and 2, 1, 0, or V can be negative 1, 1, and U here can be 1, 0, 1, and so on. There is one important vector, 0 vector, that we denoted by 0 vector, and it has all the components zeros here and here. That's the same. Yeah. Well, you have to ask me, okay, but what are the meanings of these vector? And this is where the meaning comes in. You see, this is the directed line segment. The end point is going to be a pair of numbers. Yes, it's going to be identified by a pair of numbers. You pick that end number, end point coordinates. That's exactly the components of the vector U. So components of vector U is the same as the coordinates of the endpoint of U. So that's how basically points and vectors are related. When someone says vector negative 1, 1, what it means is that you draw the vector. Vectors always start from the origin, but up to the point minus 1, 1. This is minus 1, 1. And the directed line segment from the origin to that point is exactly vector. So I used V for that. V negative 1 and 1. So that's basically what is the relation between points and vectors. Points and vectors. How about vectors and directed line segments? Well, we saw that vectors are a special case of directed line segments. The directed line segments starting from the origin are called vectors. But there's also something else, that every directed line segment for every direct line segment, let's say PQ, there exists a unique vector which has same length and direction as PQ. Well, in other words, if you draw, let me do it in R2, but I3 is the same thing. If I have PQ here, I can basically transfer this guy and just put it, the starting point, we transfer it and put it, the starting point at the origin, and the resulting thing is going to be a vector. This vector has exactly same direction and length. That vector is called equivalent vector of PQ, which is called the equivalent vector of PQ. Well, okay, so it's easy. You just shift it such that P goes to Q, and don't shift it such that it stays parallel. That will keep everything the same, the direction and the length. But how do you find the equivalent vector? Well, it's easy. If your P is P1, Q1, and sorry, P1, P2, and your Q is Q1, Q2, then the vector, the equivalent vector to PQ is, okay, here is what you do. First component of the end point is Q1 minus the first coordinate of the first one. That's the first component of the equivalent vector. For the second component, you pick the second coordinate of the end point minus the second coordinate of the starting point. End point minus starting point, the component, you do it one by one. If it is in three-dimensional case, so you have P1, P2, P3, and you have Q, Q1, Q2, Q3, the equivalent vector is going to be again, it is going to have three components. For each component, pick the corresponding coordinates of the end point minus corresponding coordinate of the starting point. For the second one, Q2 minus P2 and minus starting, Q3 minus P3. And that's what you need to know. Basically, that's the second relation that we wanted to discuss: directed line segments, and vectors. Well, that's the end of this video. We basically covered what are points, what are vectors, and what are directed line segment, how they are related, and how you can denote them, find different components, and